Hi everyone. Today we'll start with the topic as properties of determinant, which is a very important part in chapter determinant. And usually one question comes from this topic in the board exam. So that is the importance of this topic. Here we will talk about properties along with the example so that you understand it properly. So first property says the value of determinant remains unchanged if its rows and columns are interchanged. That means if A is a square matrix, then determinant of A is equal to determinant of A transpose, where A dash stand for transpose of a square matrix. Let us try to understand this property by taking an example. We call it P1, property number 1. Verify P1 for determinant equal to 2 minus 3 5 6 0 4 1 5 minus 7. All of you know you can expand by using any row or any column. So I'm expanding by using the first row. So 2 into 0 minus 20 plus 3 into minus 42 minus 4 plus 5 into 30 minus 0, which comes out as minus 40 minus 3 into 46 plus 150. So it comes out as minus 40 minus 138 plus 150. So minus 178 plus 150. Which is equal to minus 28. And let us now change as delta, you can say delta dash, which we write as 2 minus 3 5 6 0 4 1 5 minus 7. So if you expand it, you can see we are expanding by using this first row. So this is equal to delta dash is equal to twice 0 minus 20 minus 6 21 minus 25 plus 1 into minus 12 minus, so it comes out as minus 40 minus 6 minus 4 minus 12. So it is minus 52 plus 24, which is minus 28. So you can call it 2, and this you can call it 1. So 1 and 2 implies delta dash is same as delta. Here the operation which we are using, we can write as Ci interchanging with Ri, where I stand for ith row. So you can understand, if I is equal to 1, that C1 is interchanging with R1. That is the meaning. This is the meaning which you can understand here. This is C1, which is changed with R1. So interchange. Basically, it is this operation which is working here. So this is property number 1. Let us move on to property number 2. Property 2 says, if any two rows, where I am using the word row, you can refer to column also. Whatever property is working on rows, the same property works on column also. So if any two rows of a determinant are interchanged, then sign of determinant changes. So here you can understand this by taking an example. Verify P2 for I am using the same example just to save time. 2 minus 3, 5, same example. 6, 0, 4, 1, 5, minus 7. And you know the answer for this was minus 28 from property 1. Now we can interchange any two row. You can take any two row. Suppose we interchange these two. So R1 interchanges with R2. This is the property we are using. You can interchange column also. So delta becomes 6, 0, 4, 2, minus 3, 5, 1, 5, minus 7. What should be the answer? According to the property, the answer should be 28. Right? Because there will be only change in the sign. The numerical value will remain same. Numerical value must remain same. But let us verify this by expanding it. 6 into 21 minus 25 minus 0 plus 4 times 10 plus 3. So it is minus 24 and plus 52. 4 13s are 52, which comes out as, you can call it delta 1. So you can write it as 2 and this is 1. So 1 and 2 implies delta 1 is minus of delta. This is what the property says. I hope you have understood everything. If you have not, you can revise it again and understand. Let's move to property number 3. That is P3. P3 says if any two rows or column of a determinant are identical, then value of determinant is 0. Let's take an example. Evaluate you can see here this row and this row are identically same. R1 and R2, R3 are identically same. Since R1 and R3, you can use this symbol. Since R1 and R3 are identically same, this you will come across many times while doing the problem. So you can use the property when they are identically same, delta should be 0. But let us verify by calculating it. I am again expanding by using first row. So 3 times 6 minus 6 minus 2, 6 minus 9 plus 3 times 4 minus 6. So this is 3 into 0 minus 2 into minus 3 plus 3 into minus 2. So this is 0 plus 6 minus 6, which comes out to be. So this is the verification of this P3 property. There is a remark regarding property number 3. What is the remark? What is important? Remark says, this is the remark. if any two rows or columns of a determinant is proportional is in proportion, then the value of determinant is 0. That is, if I am taking here a very simple example uh, of 2 cross 2, if delta is equal to 1, 2, 3, 4, 1, 2, 2, 4, R1 and R2, they are in proportion. So if you calculate the value of determinant, it will come out as 4 minus 4. That's the meaning. Like in later on, you will see many cases where any two rows are in proportion. So if any two rows are in proportion, you can directly write the answer as 0. P4, if any two rows or column of a determinant are multiplied by a scalar k, then the value of a determinant is k times delta. If you want, we can take an example here. Like we can take evaluate. Since you need to understand this, you can create yourself 1, 2, 4, 3, 0, 5, minus 1, 3, 0. Suppose this is the value of, this is the determinant. And let us expand by using the first row. 1 into 0 minus 15 minus 2 times 0 plus 5 plus 4 times 9 minus 0. Just check. 1 into 0 minus 15 minus 2, then 3 into 0 plus 5 and 4 into 9 minus 0. So you get minus 15 minus 10 plus 36. So minus 25 plus 36, which is equal to 11. Now I multiplied this row by 2. Now consider delta 1 as 1, 2, 4, 3, 0, 5, minus 2, 6, 0. What should be answer according to the definition? The value of determinant is 11. So since I am multiplying by 2, the value should become 2 times 11. So I know in advance my answer should come 22. Let's see. 1 into 0 minus 30 minus 2, 0 plus 10 plus 4, 6 threes are 18 minus, let's see, minus 30 minus 20 plus 72. So it is minus 50 plus 72, which is equal to 22. So 72 minus 50 is, which is equal to twice of delta. So clearly this is, here the k was 2, so you got it verified. So this is what property says. If any two rows or column of a determinants are multiplied by a scalar, then the value of determinant is k times this delta. So the value of delta is 11, therefore delta 1 should become twice 11, means 22, which is coming here. So it is verified. This is property number 4. Let's move further. Property number 5. You can say this as important. It depends how you feel. If some if some or all elements of a row or column of a determinant are expressed as sum of two or more items, two or more, two or more items or terms, you can say. This is proper word. Then the determinant can be expressed as sum of two or more determinants. I hope you have understood the meaning. This means let delta is equal to this. I'm just taking an example: a1, b1, c1, a2, b2, c2, a3, b3, c3. And what happened is here some other value is added: lambda 1, lambda 2, lambda 3. This is the determinant. So what he is saying, according to the determinant, according to the property, he says if any row, some or all row or all columns of a determinant are expressed as sum of two or more terms or items, then this determinant can be expressed as sum of, since here two terms are there, so here the determinant will be split into two. So first determinant will be a1, b1, c1, a2, b2, c2, a3, b3, c3. This part will be split. Remaining two will be same. b1, b2, b3 will remain same. Only this part will split into two. So the upper part will be the first row. Since first row is sum of two terms, so you will have two different terms with first row splitting into two, and you get these two. When you simplify, this answer will be same as this. When we'll see the example, we will have a look on this. You can verify yourself also. Property number 6. The property number 6 is the most important property as per my experience, and most of the time you get the question based on this only. So this is the most important property of determinant. It says if to each row each element each element of a row, to each element of a row or column of a determinant, the multiples of corresponding elements of other row or column are added, then the value of a determinant remains the same. That is, we are talking about Ri changing to Ri plus K times Rj, or Ci changing to Ci plus K times Cj. This is what we are talking about. Let us try to understand this by taking a simple example. Let us take an example. Using property of a determinant, prove that x a purposefully I have taken this example. The reason for taking this example is that it is not that you uh, this this problem is based on this property only. This problem can be done by the previous property also, the property number 5. So I would like to take this by both. So first solution is solution number 1. Let us use this property. So we can say the question is x plus a. Many properties will be used in this question. So this question is very good to understand many properties. What we will be doing, C1 changes to C1 plus C2. So what will happen? C1 is going to change. This is C1, this is C2, and this is C3. So C1 is going to happen this way. It is not necessary that you need to multiply by a scalar. If only one time it is required, so you can do that. So it will become x plus a, y plus b, z plus c, a, b, c, x plus a, y plus b, and z plus c. We did use that property where we said here C1 is identically same. So this result, you can see this determinant, this column C1 and same as C3. So you can directly write answer 0. All right. You can do another operation here. After this, you can write as C1 changes to C1 minus C3. So it will become 0, 0, 0, A, B, C, X plus A, Y plus B, Z plus C. You can do by any way. The only thing is you don't have to expand it because the question says using properties prove that. So you only have, it means this question is based on the property only. So this is how you will be doing the properties, right? And for more practice problems, you can refer to the worksheet attached in this video. You can do the practice from those worksheet problem, and you can write in comment box whether you like those problems or not. Thank you very much.